Thank you very much, and thank you for the invitation. It's very nice to be here in this room with a lot of great scientists. So I feel a little bit nervous. Anyway, you have seen from the presentations, the previous presentation, that muscle mass is lost with aging, and usually we refer to muscle mass as either muscle CSA, cross-sectional area, muscle volume, so muscle size. But also, like what I wanted to point out in this slide, these are two vastus lateralis pictures that I acquired in a young male and an older male of 73-year-old, younger male of 27. You could see that the two scales are exactly the same. So the first thing that you notice is that there is a reduction of muscle thickness, which is consistent with the loss of muscle CSA, muscle mass, but also the architectural features of muscle, such as pennation angle, which is the angle of insertion of fascicles onto the deep aponeurosis, is reduced. And this actually tells us that not only a mere quantity of contractile tissue is lost, but also like the structural features of muscle are going into a degeneration. And if we think about the growth of muscle, we could really, narrow this in terms of addition of contractile material in two different ways. An addition of new contractile materials in series or in parallel that is related also to the radial growth of muscle. So if we think about the reverse effect, which is the loss of sarcomeric material, we will have a loss of in-series sarcomere and in parallel sarcomere as well, as we saw actually in this picture right here, reflected by the architectural adaptations. The good news is that if we stay active, even if we lose with age muscle quality and with a sedentary lifestyle, muscle quality and muscle size, with exercise, we could try to mitigate or counteract this loss of quality and mass. You can see here an age-matched MRI scan of the thigh, in which you can see not such a big fat tissue and intramuscular fat accumulation. And here you can see an MRI picture of a 70-year-old triathlete. So exercise is definitely good for us. And resistance exercise is actually one of the main, let's say, strategies that has been used to counteract or mitigate this functional and structural loss of muscle. But when we talk about resistance exercise, usually we think about something strenuous, something that is, carried out at higher intensities and closer to the maximal effort. But actually, there's a lot of research now that started around 2009, 2008, or even before. But this was the year of this paper published, that showed that actually, with 90% of the intensity of a repetition maximum compared to 30% of the repetition maximum intensity that was work matched or to fail, okay? And regarding the protein synthetic response of muscle measured by the myofibrillary fractional synthetic rate response, the 30% of the repetition maximum intensity was actually no different from the 90% of intensity used, which means that we can use actually lower intensities and we can also get hypertrophic response. And I was actually pretty happy to see Professor Hoppeler in the audience today, because I was citing one of his papers here. And actually Professor Hans Hoppeler came out by looking at the literature of Paul Lastayan, Stan Lindstedt, and his own literature, and he came out with an idea that moderate load eccentric exercise could be actually one of the best strategies to counteract the loss of muscle mass and the loss of muscle function in aging. And why? I will try to convince you that this was a really good idea. So let's talk about eccentric and concentric contraction. So the concentric contraction are produced by shortening of muscle, and the eccentric action are produced during lengthening of muscle. So there are actually two contractions that are found in everyday life, in every movement, in every resistance training movement, but are completely different. They're different because they're different for mechanisms of force production. They're different because they can produce different muscle force. and they are different also because they lead to different adaptation that we will see in a minute. So by looking at the basics and the force velocity relationship, we have the force enduring the stretching or the eccentric or lengthening phase that can be higher than the isometric force when velocity is 0 or than the the concentric force. And also, and this is a slide that I really, really like because I thought that it was a genius study in 1952. So these are two cycloergometers which are placed in series, and one could actually break the action of the other. So if two people sit down on this, one could pedal concentrically, and the other person could try to resist by eccentrically producing force. And actually, I don't remember who of the author was quite of a strong person and who was actually quite minute, quite petite, but basically the little person was able to, break the bigger person that was pedaling concentrically by just resisting and pedaling eccentrically to the force that was opposed. And this was done actually by measuring oxygen consumption and work. This was done at a very lower metabolic cost compared to the concentric pedaling exercise. So now you start to understand why Professor Hoppler suggested that eccentric exercise and moderate one could be a very good solution for all the people, because the metabolic cost would be less. But the force that can be produced during eccentric exercise can be higher. So the tension that is applied onto the muscle can be a good one with a lower metabolic cost. And moreover, the concentric and eccentric action produce two different mechanical stimuli of the fascicle behavior. Here, a rise of pennation angle and a shortening of fascicle is seen. This was a video of vastus lateralis acquired on a leg press exercise. And instead, in an eccentric action, so the lowering phase, first the muscle takes the load, and then there is a clear lengthening of these fascicles. So when you applied this stimuli for 10 weeks, okay, you have contraction measured isometrically. Sorry if I have to switch from here to here. But you also have a similar increase in muscle volume, so similar increase in muscle size and hypertrophy, but brought by two different architectural remodeling strategies. The fascicle lengthening increase is promoted more by eccentric exercise, by the lengthening exercise, and the concentric one instead produces greater increases in the pennation angle. And this actually can reflect some strategies of addition of contractile material, because if you think about the increase, for example, here is a bidimensional picture, but if you think about an increase in muscle thickness, which is related to the increase in muscle size, and if you take the same given length, so an increase in pennation angle would be seen as a strategy to pack more contractile material along the tendon aponeurosis. And it will be promoted by reflecting more addition of sarcomere in parallel, whereas an addition of sarcomeres in series can be seen by longitudinal fascicle growth. And actually, this can impact the force length relationship, because if you can understand, if we have more, for example, sarcomeres in series addition, this could relate to a shift, a rightward shift of the length tension relationship, and probably also a widening of the plateau for force production. So we decided to, because we studied this on young people, we decided to see if the same adaptations or similar adaptation would have been seen for elderly people. And so we decided to not use an 80%, so a quite high intensity stimulus, but we applied to elderly people and to young people a moderate load eccentric exercise of 60% of the repetition maximum stimulus. And the hypothesis was that the moderate load eccentric and concentric will lead to distinct architectural adaptations to differential temporal responses in muscle hypertrophy, possibly with differences between the two age groups. So this is actually what we did. We did progressive resistance training for 8 weeks, 3 times a week, of the 2 eccentric or concentric group and 2 age groups, so elderly and younger people. We acquired magnetic resonance imaging, maximum voluntary contraction isometrically, and ultrasound for muscular architecture. And we performed this training at the 60% of either eccentric or concentric repetition maximum. We used this leg press, which was modified ad hoc, so we could actually use this electric engine, which was attached via steel cable to the chair. We could follow the people on the pushing phase, so on the concentric phase, and stop the chair to not let them perform the eccentric phase, so the lowering phase. Or we could take back the chair in order to just let them perform the lengthening phase, so the descending phase of the And we decided to do this because we decided to match eccentric and concentric repetition maximum, not to match, but to use eccentric and concentric repetition maximum, because if the same load would be displaced in a force-velocity relationship, if we display different force-velocity relationship of different activation, we would fall, if the same load is displaced, from a neural activation to a lower neural activation. So one of the fundamental requirements of the force-velocity relationship is that every point of force and velocity should belong to the same level of neural activation. So we decided to use repetition maximum either concentrically or measured eccentrically. So the results, the MVC increased in both groups. You can appreciate that elderly people are, not so strong compared to the young ones. But we saw an increase at the 8th week. Muscle volume presented an increase. We measured this by MRI, presented an increase in both groups. You can appreciate, though, that at week 4, in the older males, only for eccentric training, we had a greater increase and a greater response in muscle volume compared to the age match group, but doing concentric training. If we look at the muscle architecture, we see once again that eccentric exercise promotes an increase in fascicle length, so reflecting an addition of sarcomeres in series. Here you can also see that though the response of 2 weeks in a comparison between young and older males, the younger males seem to promote greater increase or greater magnitude of increase in fascicle length, and less magnitude was found in the older male. Pennation angle, as a contrary, was more promoted by concentric exercise, as it was shown before by us also in younger people. And you would say, okay, these are quite, early adaptations, and yes, I agree with you, but this has been shown consistently first by Marco and Olivier Senez before I joined Manchester, but also we can find also an explanation here in one of our ex-colleagues from University of Nottingham that showed that actually the myofibrillary fractional synthetic rate in response to exercise in younger people, and successively they also demonstrated that in older people, is really greater in the first weeks of exercise, which matches the possibility to obtain early structural adaptations. We also measure, I haven't said that, but we had a lot of things that we measure, but for the sake of time I had to compress. We measured, I don't know what happened to the standard deviations here, but okay. We also measured tendon mechanical properties. And we saw that to moderate resistant exercise, either concentric or eccentric, tendon stiffness and tendon's Young's modulus mechanical properties can increase. They increase at 4 weeks, until 4 weeks for the young people, and then they sort of plateau but they keep instead increasing for the elderly people. And the elderly people actually reached, at 8 weeks, a level of tendon mechanical property that was very, very similar to the baseline of the young population, which means that moderate eccentric or concentric resistance training can lead to a restoration of tendon mechanical properties of the patellar tendon. So, in conclusion, even in the elderly, architectural adaptation to moderate load exercise are contraction specific. Early hypertrophic responses were observed in both groups and at both ages. Structural changes were achieved earlier and at greater amplitude by moderate eccentric loading in young compared to older men. But also, in older men, we saw a more rapid increase in muscle volume at 4 weeks in response to eccentric moderate resistance training rather than concentric, suggesting that this modality of training could be more efficient, more beneficial in the short term. Patellar tendon, instead, seemed to be blind to the direction of the mechanical stimulus that is applied on the tendon itself. So basically, the strain or the tension that is applied is sufficient. Either it is eccentric or concentric direction of the stimulus. But this, suggests also the moderate eccentric resistance training and concentric, but eccentric is probably to be favored because it's less metabolic costly and you can apply greater tension, but it seems highly beneficial in restoring its mechanical properties. Thank you very much.
Thank you for the great explanation of concentric versus eccentric contractions, which we use routinely in muscle diseases to look at fragility. And so I wondered in these exercise regimens, how much of the eccentric contraction regimen is caused by damage in terms of pushing the hypertrophy?
Okay, that's a good question. When we talk about eccentric exercise, we should always consider damage. Because this was a moderate load that was applied, we haven't seen any. We were also measuring VAS scale and Borg RPE scale, and the participant did not actually. Also, the elderly did not showed any signs of soreness, of muscle soreness. So we haven't looked at muscle damage yet, and this is what I wanted to show you, but I didn't have time to show you. But we have biopsies from these muscles, and we have biopsies at 2 distant muscle sites. We are working on this, and we're going to try to see if muscle damage or any other molecular players are behind these adaptations. As we think that some specific mechanotransductor adaptation could be lying behind these differential adaptations.
Any other question?
Hi, thanks for the nice talk. You just triggered my question because of the biopsies. Because you've shown changes in the pination angle, so are you going to look into pathways or transcriptomic changes which can then explain the pination angle change? Or whether there's a molecular reason for the pination angle apart from the logical contraction business?
So, thank you. So the study was conducted in 8 weeks, so I'll start by saying that. And every 2 weeks, we got a biopsy at 2 muscle sites for, it's huge. So we're going to try to understand a little bit more like why muscle actually responds like this to different directions of mechanical stimuli. Because now we know that it can respond differently in architectural remodeling, but we don't know why. There are some suggestions, there are some molecular players that are thought to play a role with that, and they usually are responding to tension, related to the tension that is applied on the muscle. This is something that is in preparation for a while, but this is not published. But this shows basically that some architectural adaptations are more prominent closer to the Martin-Dinas junction. And this makes sense to me because it could be, it's apart from the fact that it's a very unique place where to study everything, but also the area on which the tension is applied is less. So if mechanotransductor or mechanical tension is the role player there, we should see something. I don't know, but I hope so.
Thank you for a very interesting study, and I think it's very interesting that also that you have taken biopsies close to the myotendinous junction, because I remember that, you know, years back, like 30 years back, I did a study with Marco Naric showing that the changes, the delta changes in muscle volumes are much larger when you look close to the myotendinous junction than when you look in the middle of the belly of a muscle.
I agree. No, I completely agree. The regional hypertrophic response in response to these two type of training is something that we know, but we still don't know why this happens. So I'm fully in agreement. I would love to understand a little bit more why this happens. For rehabilitation purposes as well, or clinical purposes, it would be huge to understand this, to more precision medicine to be.
Well, I missed the point on the neural activation in concentric and eccentric contraction, so
Yes.
it is my fault. Can you comment on that, because I think it is
Yes,
interesting also.
So there are like different ways to match the two typologies of contraction. Either we can match it for work, for total work, but also because we can produce more tension in the eccentric portion of the force-velocity relationship. This will result in less repetitions that will be performed eccentrically compared to the concentric training. So we decided, Marco decided, and I think it was a good idea, he decided to basically match it for a theoretical neural activation, which means that, I haven't showed you, but there's a paper that we published in Acta Physiologica in 2014, by which we measured the integrated root mean square of the signal during either a eccentric repetition maximum and a concentric repetition maximum. And we also measured that at the load by which, so 60% or 80% in another study. And we showed that the two root mean squares were very similar. So means that, or theoretically should mean that, we should actually work on the similar or same, I wouldn't say same, but similar force velocity curve. Because in this case, you will have something that is quite comparable. The best of the best would be to measure this or to compare the two contraction for strain applied onto the fascicles. But that is very difficult to be done.
Okay. Any other issue? No. Okay, so thank you very much.
Thank you.